Hello, good evening, bienvenue, good morning, good afternoon, and wherever you are and or whatever you are. Bruce, Jonathan, and I have been banned from having our faces on YouTube. Plainly, none of us can get our cameras to work. Well, maybe Jonathan can, but he just doesn't want to. But luckily, the fourth face in the windows there, Bill Fredericks of the Advanced Aircraft Company, has managed to get his face showing. And as for all the students, the flight test students and the students from Babe High School, well, they haven't turned up. They're late for class. Maybe they are just finishing a class and it's going to be bang on time. So let's just straight into some stories that I've seen this week and I think are worth talking about. And the first one is Jonathan, your TFR article. I got ripped into by a few people for not saying what a TFR was. And that made me think, well, maybe if you don't know what a TFR is, should you really be flying anyway? So, Jonathan, run through that article.
Sure. The TFR articles, I actually wrote that a long time ago. TFR stands for temporary flight restriction. The FAA has the ability to, designate certain areas for different reasons. There's about 8 different, I believe, regulations that they can use to actually kind of quarantine an area for some specific purpose to prohibit aircraft from flying in there. And so that manned aircraft watch out for those locations, and droners are supposed to stay out of those locations as well. And so what happened just recently here with that NOTAM announcement of the 133 locations, you're not allowed to fly in there because those are basically TFRs, security-related TFRs. If you violate that, the FAA can come after you, as well as the Department of Justice can prosecute you criminally, and I believe it's I think a year in prison up to and/or a $100,000 fine if you violate that.
And 133, somebody reached out from the FAA very quickly to say it's nothing to do with the heightened security risks over there. Please amend what you've written to reflect that. The FAA said they were working on those 133 new flight restrictions for a long while. Do you get a sense that was the case, Jonathan?
I think so, because that ArcGIS map that I saw was actually created back in January.
Yeah, no, I think so as well. Quite surprised that anyone would consider flying over military bases and things like that. That to me would be a no-brainer straight out the box.
Well, I would agree. I mean, a lot of those military bases have restricted airspace over them, but they were restricting the airspace now over them that you could normally fly over with your drone. So this is only for unmanned aircraft, so you can actually fly over these locations with a manned aircraft. It's just with unmanned aircraft, you cannot.
And then, so leading on from that, that's the FAA's airspace maps. Everyone's getting rather excited about that. Is that going to make their permissions quicker?
Potential. I mean, I don't know if it would make it quicker. I think it maybe make it a little bit more accurate, but at the same time, I think it also might bog the system down because people have a better idea of how to actually file the stuff right now. And so it's easier to say no to a whole lot of people than it is to actually try to go about proving them. So it potentially might actually bog the system down further.
Yeah. I think there's a lot of misunderstanding about where that's going, isn't it? It's just a grid that's going to show what the requirements are for a particular bit of airspace near an airport or built up area. Am I right in thinking that?
Well, I mean, yeah, you have a clue of what's going on. I mean, you saw on the map where they did actually specifically list out kind of like an example of where you could and couldn't fly over at New Orleans. So, I mean, people can kind of get an idea there. All this is being released on April the 27th, which coincides with the 56 days for the like chart supplements, instrument approaches, and stuff like that. So they're kind of aligning it with what they normally do with the publication cycle.
Yeah, it's and the other sort of FAA bit of use that's sort of linked but not quite into all this was that they released another set of numbers for Part 107 pilots that have joined the fray, and I was quite surprised that there wasn't very many more.
Yeah, I had someone actually email me about that, and we're trying to kind of figure that out potentially is that if they maybe misspoke and said something like it was the number of people who took the remote pilot knowledge exam. So that was kind of one possible to why that happened. I'm getting some crazy echo.
Yeah, I think that's because the Mesa RC guys have joined, and they're running some wicked feedback with us.
Sorry.
That's all right. That's all right. G'day, guys. Welcome. Very glad to have.
BB8's on another, or not BB. BB is from Arkansas. Those guys are on a different hangout.
Okay.
Yeah,
cool.
might send them an email or something because they're just sitting there waiting too.
Oh, okay. I don't know what happened there, but you can probably see that Bruce, Jonathan, and myself don't have any video, so I don't know what's going on. But it's nothing lost. Obviously, it's important to see Bruce. He's very attractive down there in New Zealand. So we're just going to. Yeah, I'm sure you can, but we can't see your choice of hat today, Bruce. That's what I'm missing the most. Well, let's come to Jake Marshall and the students from Mesa RC. You guys really are the future of this industry, and boy, I am so jealous that this sort of thing wasn't happening when I was at school. Maybe Jake, can you run us through what on earth you do, how it got started? Just tell us a life story there.
Okay. I think Mesa RC started about 6 years ago, and it started as an after-school program with only 2 kids. And since then, those 2 kids are now seniors, one at Embry-Riddle Aeronautical University studying aeronautics and airspace. And then we have another student who's a mechanical engineer at Mesa State. And then from there, we just kind of, more kids found out, and we kind of grew and grew and grew to the point where we had 60 kids after school meeting up to scratch build planes. And the principal said, let's get it into the classroom as an actual class during the bell schedule. And so that's when we had our class during Pride. And then there was a request from a lot of our followers on YouTube, because we started YouTube right off the bat, doing our show. And there was a bunch of people wanting the plans that the kids were creating. And so that's when the kids made a decision to kind of become like a business and kind of follow a business model, along with learning aviation and design thinking. And from there, it just kind of exploded. So it's kind of busy every year, guys.
Wow, we are not worthy. That is really fantastic. And let me just hear that again. This is actually a class during school time.
Yes. Yep. It's a class during school time. We self-fund ourselves from the kit sales that the kids generate and sell on through a consignment deal with one of our dealers. The kids manufacture and produce all of their own kits. JoJo is here. She does product management. We have 2 laser cutters that we've been able to achieve through grants. We've got 4 to 6 3D printers that we've been able to achieve through grants all around the foam airplane. No one else was doing it, so we looked good around our area, and so companies like Otterbox and AutoCare supported us and supported their journey through this. They're fully equipped to do whatever they want to do, really. It's just a matter of thinking it up and engineering it and putting it out there.
Wow, that's fantastic. My jaw, it's a good job the camera's not working, because my jaw is on the floor. So you have a very progressive principal at your school then. Are there other what am I trying to say? Are there other avenues, other parts of the curriculum that would differ from other mainstream schools? It's a very good art department or a very good drama department as well. Is it a super progressive school?
Yeah, the principal at the time was Miss Warner, and she, when we said we wanted to fly drones out in the back of the school, or planes, or these foam board airplanes, she didn't really understand it quite right off the bat. And then once she saw the amount of engineering the kids were doing, it was just, what do you need? 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 And we actually taken what the kids have done over the past 5 years. We partnered with Flight Test over the past 2 years to develop a curriculum that we can hand off to other schools across the country, and even the world, because it's now in Europe too. Kind of like a game plan to deliver this to kids. These guys are all 8th graders? Yeah. All 8th graders, 7th graders. And we've got middle school, high school, and even elementary schools too, curriculum through Flight Test. And they kind of helped us take this idea and spread it to other schools. So it's currently in over 300 schools. There's like 300 plus teachers that are doing the curriculum, and probably a little over 500, 600 enrolled students that are online.
That's just fantastic. Bruce, this is very much your area, education and safety and moving things forward. What do you reckon of this, mate?
It's fantastic. I wish I'd had something like that when I was at school. And as somebody that really tries to go and promote this hobby, my hat goes off to you guys. That's amazing. You know, it's an incredible resource for the kids in that area. And yeah, what can I say? I am gobsmacked. Fantastic, guys.
It is amazing. And do you guys plan on an aviation future, or where do you think this is going to take most of you students there? Where do you see yourselves being in 5 years? Oh, such an old man thing to say, isn't it? Where do you see yourself when you leave school?
I kind of want to go into engineering, since a lot of helps me work in CAD and get a feel for how to use the engineering programs.
Kind of comes like an outlet opportunity, so kind of get down those skills before kind of start off in high school and then in college.
Wow.
It helps us persevere through challenges that are given to us, like the challenge Flight Test gives to us to create 3 different things.
Did you guys hear that?
Sorry, say again?
Okay. This class gives us an opportunity to persevere through challenges like the one Flight Test gave to us, to create those 3 Alpha, Bravo, and Charlie planes.
Yeah, I saw that. I think, yeah, I've watched you guys for a while, and I have one of my sons who's 13 who would, yeah, he would just die to go into that class. It's just fantastic.
Yeah, just a question. I noticed there's 50-50 ratio of male to female there. Is that indicative of the total thing, or have you just sort of got half and half for the purposes of the webcast? Because I really like seeing the engagement of this technology and this hobby with members of the fairer gender, because it's not often you see that. Generally in the hobby, there are very few women involved in the hobby. So that's fantastic to see young women there, and especially talking about engineering. Wow, that really sort of, you know, I get excited by that.
Well, actually, there's only 2 other girls in the program. JoJo works in production. Cecilia and Mazzy are in the ground crew, and it's me, Delaney, and Kelly Stuckey. We all work in air, so there's actually more boys than girls, but it's definitely fun.
It's good to have a mix.
Yeah.
It's definitely.
That's great to see, girls. You know, I hope you have a really good future in the industry and the hobby.
And so you're running it it sounds like a business. So do you have business meetings, and do you make decisions as a group? How does the decision making process work? How do you come up with a design and then say, this is the one that's going to make it through and we're going to produce this? Perhaps you could talk us through that process.
Okay. Well, the business piece, we have Monday meetings. And during the Monday meetings, we kind of plan out the week, who's flying, what projects are at the forefront that needs to be either prototype or cut out using the laser cutters, or just them communicating to me as to who needs to go out and test, or what we got coming out. Because we also do, which is not needed, the YouTube element of it, which we don't need to do, but it helps promote us, and it helps keep them accountable too, having deadlines and all that. So we run an episode every Wednesday and Friday, and we also have an editing team who cares nothing about planes or engineering. They are more into cinematography, videography, and so they have to try to take the content that's developed by the engineers and actually make it into a story that we then put out every Wednesday and Friday. But from concept to the shelf, it really comes down to what the students are interested in. Sometimes there's a need for right now. The need is, can we make the planes that we currently have mini, I guess, to scale. And so we just kind of throw it out there, and it's on the work table saying, hey, we need to make these 3 or 4 planes mini in size. And then we have engineers who then take on that problem. So Jill's working on the Eclipse, which is one of our planes. She just flew today. Yeah. And how'd it go?
It was pretty good.
So this is her plane, and she's using the standard BPAC motor that flight test sells. And so you were in prototype mode, right?
Yeah.
And so from prototype, she then goes into finalizing. You got a couple more things you have to do, right?
Yeah, just a little.
Cool. And then she'll do a whole video, a build video and a maiden video for the release of it. And then she'll release the plans out to the public. And then from there, it goes on to JoJo. And JoJo then has to produce them based on demand, and just kind of based on our feedback from our social media. It's like how much of it should be produced. Usually we kind of go small to begin with, and then we'll look from there. And then she makes sure that our consignment dealer has everything that he needs, so that he's stocked. And so yeah, it kind of goes from that. It's an engineering cycle that they go through. So they put a little bit of research in behind the problem. You go and they build it or design it, build it, test it, test it, test it, test it again until it's perfect, and then that's when we release it.
Absolutely. Yeah, I was going to ask you how many flight hours would an airframe generally get before it's released?
I would say 2 hours, 2-3 hours.
And then how many? Sorry, how many aircraft have you released to date?
I don't. It's probably somewhere around.
No way.
No, it's probably somewhere between. It's probably somewhere right around
30 to 40.
Different types of design, 30 to 40 different designs.
Correct.
Wow, in 6 years, that's pretty amazing. That probably outdoes Bruce's production rate. I don't know if you've seen Bruce is that curmudgeonly old man from New Zealand. But anyway, enough of that. No, he's not. I can't tempt him out. He's probably seen his channel, RC Model Reviews. He's done some amazing things over the years. Now, have you guys seen Grease Lightning? And I don't mean Grease Lightning as in the movie Grease. Do you know the airframe I mean by that? Let's see if I can put a picture of it up. Let's see. Let's see. Have we all seen? Is this working? Is this working at all? Have we all seen that thing?
Yeah.
Seen that thing? Well, we've got just the man to tell us about that thing. Sat very patiently there is Bill Fredericks from the Advanced Aircraft Company. And Bill, we'll come back to the guys at Mesa in a minute, but you were part of Grease Lightning, I think, weren't you?
Can all of you guys hear me okay?
Yeah.
Wonderful. So the direct answer to your question is yes, I was intimately involved in it. In fact, I ran the project at NASA, and I did the conceptual design of the aircraft. And like most NASA projects, whether it works or it doesn't work, when the project's over, you put it up on a shelf, the team disperses, and you go work the next project. And I kind of thought to myself, well, rather than being a government researcher trying to push on a rope to advance technology, why don't I start a company and commercialize it myself? And that was the genesis for Advanced Aircraft Company. So I'm still actually part-time at NASA while I'm building Advanced Aircraft Company. And started the company with the intent of putting Grease Lightning into production. Doing some business planning, I'd have to raise a lot of money and 3 to 4 years of development time before I could start generating revenue with that product. So I decided to pivot. And the pivot is to our other aircraft called Hercules. And Hercules is a multi-rotor drone, or UAS, and it's unique in two ways. One, it has a bunch of aerodynamic efficiency improvements, and two, it has a hybrid electric propulsion system in it. And the net result is, well, let me back up. Most multi-rotor UAS on the market today, or actually I should say every multi-rotor UAS that's on the market today is battery powered. And it can only fly for about 20 to 30 minutes before the battery runs dry. And our Hercules can fly 2 to 3 hours, depending on payload weight. So a massive improvement in flight time. And the reason why that's useful is our customers, which would be the UAS operator, they generate revenue proportional to the amount of imagery data they've required, but their costs are driven by the labor costs of their workforce. And so if the aircraft can spend more time in the air taking images, less time on the ground with the workforce dinking with it, the net result is a better profit margin for our customers. Oh, wonderful. I see a picture up there of the Hercules. So the top left picture is the Hercules. And you can see the unique features, those fairings that look like wings on the rotor booms. They're actually not wings. They're free to pivot like the weather vane on the roof of your house. And that provides a significant drag reduction. And then the grease lightning there is the lower picture shown on the screen.
You're going to have to wind back on that a little bit, Bill. You say they're free to pivot and they decrease drag. And if you're able to explain that, and it's not too much of a trade secret, what did you mean by that?
So, so this is now starting to get into aerodynamic theory, but let me see if I can keep it at a high level. So there's three types of airflow. There's a laminar flow, there's a turbulent flow, and there's separated flow. Laminar flow has the least skin friction drag, and people talk about like laminar flow wings, really efficient and things like that. Most airflow is turbulent, and then separated flow is where the air is no longer attached, or what pilots would call the wing has stalled, and the airflow separates from the surface. The drag associated with separated airflow is massive, and a cylinder in a crossflow has a whole bunch of separated airflow and lots of drag. So if you look at the effective lift to drag ratio of a typical multi-rotor, it gets an effective lift to drag ratio of 2. But a typical airplane will get a lift to drag ratio of like 12 to 16. Massive difference. That's why fixed wings can fly so much more efficiently than multi-rotors, because they're simply so much more efficient. So with the Hercules, we're trying to pick the low-hanging fruit and take a multi-rotor and put on a whole bunch of drag cleanup features and add a hybrid electric propulsion system in it, kind of like what a Chevy Volt does, the car. A Chevy Volt, you got a gas engine, spins a generator, produces electricity, and then that powers all the motors. So that's our first product, Hercules, that we'll be commercializing and starting deliveries of this fall. Grease Lightning will be our second product, and that's going to be starting to reach the market. We're planned for 2019, so a little over 2 years from now.
Wow, that's very cool. But I'm going to have to say, Bill, don't you think if you had a program like those guys at the Mesa RC when you were at school, you might be 3 or 4 more years ahead of where you are now? What a cool thing.
Yeah, it's interesting. When I was in high school, at my school, they let these things called like independent studies. And I did an independent study of kind of like what you guys are doing now. And it's really cool that it's an actual class at your school. And sort of the advice I'd give you all is the opportunity you're getting now is just phenomenal. Soak it up like a sponge. And the most specific feedback I would give is try to build an intuitive sense of what sort of vehicles fly and what sort of vehicles crash. And build an intuitive sense of if you build an airplane this way, it works nice. And if you build an airplane this way, it doesn't work so nice. And without getting into any engineering details, you can still build a lot of intuition with the work you guys are doing, and try to stick that in your brain housing group for later in life.
Yeah, it's pretty sound advice. And g'day, I think we're being joined now by the guys from, I'm going to get the name of your school wrong, guys. Is it the Beeb or Babe High School? How do we say that?
Baby.
Beebe, there we go. I knew I'd have it wrong there somewhere. You guys, you can probably see there's the flight guys here, flight test STEM guys from Mesa RC. We've also joined Bill Fredericks, Advanced Aircraft, and Bruce Simpson in New Zealand. John's from Rupert, our lawyer. Now, you guys over there at their high school have passed your Part 107s. That's pretty cool.
Thank you.
So what are you going to do with that? What's the point?
The point is to ultimately have another job option and to make money.
Fair play. Fair play. And can I ask, what sort of aircraft did you use to take your test? Oh, no, you don't do the flight test over there, do you? It's just a written test.
Yes, sir.
And what aircraft do you fly normally anyway, then?
Our classroom aircraft that we have right now is a 3D Solo, 3DR Solo.
Okay, cool.
And Andrew is bringing over taking her.
Yeah. Yeah, a little bit of feedback. So that's cool. No, well, fair play to you. It's a great thing that you've done. So what are you, about a year out of finishing school, or are you 2 years out?
I'm actually a senior. My last day of high school is April 28th. We got Andrew right here. He's a sophomore. And then John is also a senior.
Okay, cool. So do you think there's a future then in the unmanned aircraft world for you? Where do you want it to take you? What do you see yourself flying or doing in the very near future?
I mean, there is a lot of different job opportunities you got to think about, just from either surveying or aerial photography, but also the software part of drones and developing software for them, and possibly some hardware for them.
I think it's really fantastic that so many, all you youngsters there are moving forward and coming into this industry, because you are the future. You're born into it. You're not duffers like us that have stumbled into it. And I think it's fantastic, and I wish you every success in whatever happens to you in the future. And I want to just jump back now quickly to Bill, who's very patiently there, and also bring Bruce in. Bruce, have you been looking at that photo? Let's bring that photo up of those aerodynamic advances up again, and see what you have to say. Have you got any thoughts about all that sort of thing, Bruce?
Yeah, I mean, it's one way of looking at it. I've always been a little bit sort of skeptical about this sort of combined hybrid vertical takeoff and fixed wing craft, because you end up with something that's got the disadvantages of a multi-rotor and the disadvantages of a fixed wing. So although there are possible advantages, you got to weigh them up against the disadvantages, and properly implemented, it might be an effective way to go. But I've yet to see one that really delivers on the potential promise of these things. The hybrid aspect with the petrol, or the gasoline and electric generator thing, is something I think we're going to see more of until battery technology takes off. But yeah, I would say I'm still sitting on the bench on this one.
Yeah, I must admit I'm there as well. Bill, what can you do to utterly convince us?
I'm sorry, I missed the question. One of my employees walked into the office.
Well, really, Bruce and I are just saying we're not overly convinced by your machine. So you put it better than I do, Bruce. You go again, Bruce, with what you said.
I'm just saying that when you've got a hybrid, which is a combination of multi-rotor with vertical lift and fixed wing, you may end up with the advantages of both, but you also end up with the disadvantages of both. You get a lot of parasitic drag, because you've got all those propellers. Even the propellers themselves, when they're spinning in a forward thrust direction, you've got, for example, on one of them I can see here, what do we got? We've got 8 engines. So that's 16 propeller tips generating losses through the tip vortex. A single propeller is going to be heaps more efficient. And so I guess in some specific applications there's going to be a benefit, but as a general purpose machine, you know, the compromises are quite significant, and it would be interesting to see, you know, the actual quantify the benefits in particular areas. But at the moment, as I said to Gary, I'm sort of sitting on the bench on this one. I'll wait and see what happens in the real world as opposed to, you know, the theoretical world.
So your question about quantification, and that's my background at NASA. I'm an aerospace engineer at NASA, focusing on aircraft conceptual design. And that's the exact kind of trade studies we do all the time, whether it's quantifying a fuel burn benefit for an airliner or down to even at the UAV scale. So to start answering your question specifically, are you referring to the Hercules aircraft or to the Grease Lightning aircraft?
The one I saw there, which had 4 motors on each wing, it was like, it's almost like a canard with 4 motors on the main lift wing and 4 motors on the foreplane.
Okay, so the Hercules, which was the top image, correct?
Yeah, that's right.
So the Hercules is not a transitioning aircraft. It is a hovering aircraft only. You'll notice in that image that the motors are still upright. So the Hercules is of the class of a multi-rotor. It's not competing against the class of fixed-wing VTOLs. And its acquisition price reflects that. So the Hercules is a multi-rotor with improved performance, which is not the case of a Grease Lightning, which is a fixed-wing aircraft that can do VTOL.
Okay, just looking at the Hercules then, surely those horizontal lifting surfaces are actually impeding the rotor wash from your props. How's that improving efficiency?
Actually, they do not at all. If you imagine a weather vane on the roof of your house. So do you know how a weather vane always naturally points into the wind, no matter which direction the wind comes from? So with these bearings, with careful design of the airfoil's camber line and a mass counterbalance that's not depicted in the image, and the center of mass of the fairing relative to the axis that it rotates about, the fairing passively pivots just like a weather vane. So if when you're in hover, they're passively pivoted to leading edge straight up towards the sky. And as the vehicle pitches forward and starts building forward speed, it passively trims to whatever angle it needs to be for the best lift to drag ratio. So there's no servos, no mechanical drive. It's all a passive aerodynamic device, and we're patent pending on those technologies.
Okay, I can see that. And what about, I mean, obviously you've got a mass counterbalance, so you're adding dead mass to the thing. So as I say, it's all about trade-offs. You're gaining in one area but losing in another. To have that passive, automatically angling airfoil, you've got extra mass that you wouldn't be carrying in a normal multi-rotor. Plus, you're looking at, you know, you've got 8 motors on there. As I say, you've got 16 sets of tip losses, which they're a significant energy thing. If you just simply shrouded those props, you may find that you're getting an overall improvement in your thrust to watt ratio anyway, wouldn't you?
All right, so you got 2 questions there. Let me answer the first question, was regarding the mass counterbalance. So yes, I agree with you. So as I was doing this design, the shape of these fairings came out to, and the sizing, those 12 fairings came out to about 4.5 pounds of weight, which is reducing 4.5 pounds of payload that the aircraft could carry. And having done that, I decided to myself, well, what if these fairings could be designed with a reflexed camber line on the airfoil? So at the cruise condition, these fairings, when the aircraft is flying an edgewise flight forward at about 40 knots, the lift that those fairings generate is a little bit more than their weight. So now we can have a significant drag reduction with no weight penalty at the cruise condition. The other thing I should say is if the operator wants to use the aircraft for a hover-dominated mission, so like let's look at a use case. In the case of precision agriculture, you'll be flying up and down a field at a high airspeed. in that use case, you would want to put the fairings on. Say we had a different use case where you were inspecting a wind turbine and you're going to spend most of that time in hover. In that use case, you would simply not use the fairings. So the fairings are modular. They're quick to attach and detach. So if on day one you were going to inspect a wind turbine, you just simply wouldn't put the fairings on. On day two, if you're going to go do a precision agriculture job, it'd be better to put the fairings on and get the drag benefit than to have the booms with all the separated drag on them. Does that answer your first question about the weight hit of the fairings?
Yeah, that's reasonable enough. So ultimately, this is a configurable craft. So that what we see in the picture there is not necessarily the operating configuration, depending on the mission type.
Yes. And then the second question regarding number of tips. So there's a lot of factors into hover efficiency of an aircraft. The primary factor into hover efficiency, and by hover efficiency, I mean power required per unit of thrust. The primary driver on hover efficiency is disk loading. And disk loading is the amount of swept area of your rotors as a function of the amount of thrust on that rotor. So if you had, let's imagine a Cessna 172 and a Robinson R-22 helicopter. Both aircraft have the exact same Lycoming 4-cylinder engine in them. Both aircraft can put out the exact same amount of power from their engine. But if you tried to take a Cessna 172, pitch it up on its nose, and hang it on its prop, you couldn't do it because you can't generate enough thrust. But we also know that a Robinson R-22 helicopter can hover. It can generate more thrust greater than its weight. Why? The difference is the size of the rotor or propeller and the disk loading. So in the Cessna, you're putting 160 horsepower into a circle that's about 6 feet in diameter. But on the R-22, you're putting 160 horsepower into a circle that's 30 feet in diameter. So the amount of thrust you can generate per unit of power added is much different. So when we look at Hercules specifically now, we're biasing the aircraft towards as low of a disk loading as reasonably possible. But I still want to use commercial off-the-shelf motors and propellers. So we're using the T-Motor U8 Pros and the 29-inch diameter props. So that's about as low of a disk loading as we can reasonably go. You were addressing a second order effect, number of propeller tips. So you are true that at each propeller tip, you're shedding a tip vortex. And obviously more tip vortices would be more drag. However, for a given diameter of your propeller or rotor and a given amount of thrust, there's also a trade-off on number of blades for that circle for that same amount of thrust. So, and the details of which is better depends on all the other assumptions rolled up into it. But it's not necessarily always true that fewer number of blades is more efficient.
Wow.
No, that's good stuff. And as I say, it's probably the devil's in the detail, working out, balancing each factor against the other. And that's the difficult thing that makes it so exciting working in this whole industry is, as you say, depending on the way something's configured, tip vortex may have a significant factor on one craft, it may be very low factor on another. And I kind of like what you're doing there. That passive aerofoil thing is actually a really cool idea, because one of the things I've noticed, certainly in racing drones, is people think that a tube is low drag when in fact it's one of the highest drag forms. And
correct.
Fairing
and
a
that's
tube
exactly
is
what those fairings are for, is to get rid of the drag of the tube.
Yeah,
there
that's
you
a brilliant
go.
way to reduce the drag.
And just so I get it right in my head, the reason I'm seeing the gaps running along the wing there is because they've got a pivot. They're each
Yes,
pivoting.
that's where the bearings are located.
Yeah. That's this is going to sound rude, but a lot of things that are cool are really obvious once you've seen it done, but it's not that easy to get to that point. So I don't mean you've done something easy. I just mean it's like, oh yeah, of course, and that's very cool in my mind. I'm sorry, I didn't mean to insult you.
I agree completely. I mean, I always like to say the sign of a professional is someone who can make it look easy.
Yeah, absolutely. Yeah.
Are they also landing legs? Would they not touch the ground first?
The length of the landing legs is long enough such that when the fairings are upright, the fairings don't hit the ground.
Right.
And just run through. So they're coming. These are in. So, all right. What about some numbers then? How high? How fast? How long? All those other good things. What sort of size is the machine? What sort of size is the Hercules? That image doesn't really tell us. How long will it fly for, and what's its payload?
So the Hercules is a multi-rotor, like many of the other battery-powered multi-rotors, but it's not limited to battery energy density. The size of the aircraft is similar to other commercial multi-rotors. So its maximum takeoff weight right now is 38 pounds. So it's a good size aircraft, but it still fits within Part 107. The actual dimensions of it, rotor tip on one side to rotor tip on the other side across the span, is 13 feet. So it's dimensionally a large aircraft. Having said that, we're also designing it to very quickly break down and pack into two cases. The four booms go into one case, the fuselage goes into a second case, and I own a Ford Escape. And you just throw the two cases in the back of the Ford Escape and away you go. So it very quickly breaks down into two cases that you can put inside a small SUV. Regarding performance, you asked how much it can carry, how long it can fly. And the answer to that question is a function of how much you can carry and how long you want it to fly. So there's a trade-off. So you can trade payload weight for fuel weight, and the useful load, which is the sum of fuel weight plus payload weight, the useful load is 11 pounds. So if you put 11 pounds into gasoline and carried 0 payload, it can fly for 3.5 hours. Now, all the other battery-powered multi-rotors, they're only doing at most 30 to 40 minutes of flight time. So a vast improvement in flight time. Then on the flip side, with an 11-pound useful load, say you put on 2 pounds of gas and 9 pounds of payload, you could fly 30 minutes. And then you can draw a straight line between those 2 points as to, say you had 4 pounds of payload, you could fly 2 hours and things like that.
Wow, that's quite a jump, isn't it, on a lot of other machines? Go on, frighten us with the cost.
So we're competing against an equivalent battery-powered multi-rotor with the feature set we'll be implementing in our Hercules. Will cost about $25,000 in terms of the amount of payload it can carry and things like that. Our Hercules, we're going to target a price point of $60,000, but we haven't locked that in yet. We'll start production and deliveries this fall. So you might ask, wow, you're going to charge more than twice as much for an equivalent aircraft. And my answer to you is yes, because for the customer, it's cheaper. If you look at our customers, which are the service providers, their business models are driven by their labor cost, and their business models are relatively insensitive to the acquisition cost of the aircraft, assuming you're a busy operator. They generate data proportional to the amount of imagery they've taken. So if they image more area, they get paid more. But their cost, they're still paying the same hourly wages to their employees. So with a battery-powered multi-rotor, most service providers are only getting about 3 to 3.5 hours of productive data time in that 8-hour workday. If you have an aircraft that can spend more time in the air taking an imagery, less time on the ground with the workforce dinking with it, that's a much better utilization. And their cost per acre using a Hercules could go down as much as 45%, which is a phenomenal margin for a service provider. And what's even more exciting is I mentioned they have to pay almost more than twice as much for the aircraft. With that cost per acre savings for our customer, and they're a busy operator, they're working Monday to Friday, 8 hours a day, they can break even on their capital investment of buying our more expensive aircraft in as little as 11 weeks. And you rarely see that in industries. And the reason why that's so exciting is their business models are driven by their labor cost, not by the acquisition cost of the platform.
And I suppose an important and key thing when you go with endurance is it's less takeoff and landings as well.
Yes,
and that's
absolutely.
an awful lot less risk.
It just stays up in the air and it keeps taking data.
Yeah, I know you've got to go, Bill. So we'll let you go. But I think you've got your pilots and your future, your operators, the two schools there, and those guys need to be convincing their employers that this is a sort of machine that they've got to fly. So where do they come and view these things test flying? And why don't you go on you need to do 2 school trips there across the country, demonstrate to these future pilots what's what. Where are you based? Where would people come and see you for a flight test?
Advanced Aircraft Company is located in Hampton, Virginia, which is southeastern Virginia. And kind of the biggest nearby city is Norfolk, Virginia, but that's on the other side of the water. But yeah, Southeast Virginia is where we're located. And yeah, I would love for you all to keep in touch. And our website is very sparse right now. And once we get ready to start taking orders for the aircraft, we're going to upgrade the website and get a lot more information on there. And yeah, as you guys go to work for services providers flying drones, tell your boss about, hey, I heard about a new aircraft that can fly a lot longer and make our company a whole bunch more money.
And that's right. And then the other thing is the Mesa RC guys can copy it mercilessly now that you've told them exactly how to do it. So I look forward to their low-cost version of your thing, made a foam board for us to all experiment with.
All right.
Shame, man.
Any final questions before I sign off?
Yeah, the Mesa RC team would love to be able to fly your prototypes or any testing of your. No, I'm just kidding. No, we'd probably get in trouble with anything that big in our campus.
Yeah, it's a big aircraft. You have to be careful around it.
Some of that, I guess, all of what you were talking about, and Bruce, you had great questions too. Just to let the kids kind of hear this type of communication going on. A lot of it, you have to kind of dissect what you're trying to say, because some of it's foreign language to them. But some of the questions that came out were good ones. Is what would be somebody, like, what's your target audience? Like, who are you trying to sell this to?
The Hercules, who are we selling it to?
Yeah.
We're selling it to the UAS service providers. So to use an analogy of the manned aircraft industry, Boeing makes an airliner. Boeing sells their airliner to American Airlines. So we're like Boeing. We make the aircraft. We sell it to the operator like American Airlines.
That full sense.
Cool, man. Well, I know you've got to go in a minute, you told me. So thanks very, very much, Bill, for joining us. I'd love to have you back on again, and we'll bend your ear. Thanks for putting up with our questions. And I wish you every success with getting this forward. It is very exciting. I think, well, actually, I know I have one more question. I'll give you 30 seconds. Are you prepared to tell us what flight controller you're using? I know what you used in the Grease Lightning. What did you use on this one?
Currently, we're using the new Pixhawk 2. So we've had to do a little bit of source code modification to Arducopter to fly our aircraft. Right now, we're going to start with Pixhawk 2. And depending on what customers want, if they want a proprietary autopilot, we'll be integrating those for those customers who want to upgrade the autopilot.
Fantastic. Well, that's a great choice of autopilot. And I think, did you not use the KK board in the Grease Lightning?
Yeah, during the NASA research phase, we used the KK2 board with Open Arrow VTOL, and that always needs to be hand flown. There's no autopilot functionality on that controller.
Yeah, no, fantastic. Well, yeah, I know you have got to go now. Thanks very much, Bill. We'd love to have you back on again. And we didn't even
Sounds
get
good.
you this week.
Have a great day, everyone. Thank
Look
you.
after yourself. Thanks very much. All right.
Bye.
Once he's gone, we can start talking about him. Yeah, there we are. Right, good. We can start talking about him now. Jonathan, we've kept you very quiet. Have you got any comments about all these youngsters coming into aviation? Is it a good or a bad thing?
I think it's a good thing.
Oh no, he's back to his short answers. Oh dear.
Yes.
He's a lawyer. Unfortunately, whatever you do, you youngsters, don't go into law. That's all. What do you reckon, Bruce?
Yeah, I noticed he won't give any opinion without payment.
Available to comment for a small fee. But there's education programs at your part of Embry-Riddle, Jonathan, and couldn't these guys filter into that? And they have their own sort of little research area and stuff. I don't know if you know much about that.
Yeah. So Embry-Riddle has, getting very focused on unmanned aircraft. They have a bachelor's degree in unmanned aircraft systems, as well as I believe they have a master's also. And so, they're trying to, if you will, make their program, I think, the preeminent one here in the U.S. Because they have a great tradition of being just exceptional in manned aircraft, and so now they're branching out even more so into the unmanned aircraft realm, and they have very good faculty. So that's one option there. Embry-Riddle and other universities as well are also getting into this area. So I would highly suggest probably reaching out to some of those and finding out what your options are for college at some of these locations if you are interested in continuing unmanned aircraft. Learning more about that field to potentially work in that industry.
And I think if they're very much going to be, and I'm sorry to sound like I'm gushing, but you young guys probably don't realize, old duffers like me and Bruce, the Commodore 64 VIC-20 old computers back in the day, they were sort of ahead of the game, and youngsters got a hold of them and got into computing, and were ahead of the oldies. And that's where you guys are at. You're ahead of an awful lot of older people, and when you turn up, your CV is going to look much, much, much better with the experience that you're gaining now in all sorts of fields of work. So I am gushy a bit. Sorry, I'm stop gushing now. I'm very impressed. Bruce, I think you wanted to moan a little bit about who's looking after everybody these days, and is there a unified body? What was it you were going to say about that?
I never mind, Gary. You know that. I'm always very positive and upbeat. I know it's just raising the issue that there's now so many people flying drones and so forth. In America, over 770,000 people have registered, more than the number of pilots of full-size aircraft. And we're all just this sea of people with a common interest, but we've got no representation. There's small groups, industry groups, and little localized groups, and I think even groups that represent women, but there's no group that represents all the people who enjoy flying drones. And I think it's time for that, because right now, as we've seen in Canada, governments don't have a clue what they're doing. They come along and pass some ridiculous rules because they don't really understand the problem. And because we are not unified, we don't have a single voice, we're unable to counter those silly regulations that serve no purpose. We need to get together. Someone needs to create an organization where you can go along and register, and then that organization can speak with probably millions of voices behind it, and then you have some weight, some power, some ability to change the shape of regulation and to bring some common sense to the whole regulation problem, because at the moment it's just ridiculous.
It is a bit of a free-for-all, isn't it? Jonathan, what do you think?
I agree. So with currently kind of what's going on here in the U.S., we've had the Academy of Model Aeronautics, which has been around for a while. There's also another community-based organization out there, like the Drone Users Group. Patrick Egan also with RCAPA. And so there's been like 3 of them, but also, it takes money to represent, and everybody's very just busy with their lives. Just there's a lot of disorganization going on, and I think that the time is ripe. The question is whether or not people will pony up some dollars and start paying people to actually fight these causes, because at the end of the day, you get what you pay for. People can only do free so long before people burn out. And so I think at this point, everybody listening should definitely consider setting aside so many dollars, per month to dedicate to some organization that they feel is properly representing their interests.
Just one word, Jonathan: pro bono.
Well, yeah, pro bono. Yeah, but the problem is pro bono. Everyone and then they stick it to the poor lawyers and say like, oh, you guys make a lot of money. You guys should do pro bono your life out. And it's like, we have families too. We need to put food on the table. And just because you're a lawyer doesn't mean you can go run around and fix all the problems in the world. So everyone needs to realize that you get what you pay for, and to rely upon people to kind of jump in and, pick up the slack. It's just a really bad way to do things. You're going to get what you pay for. That's what it boils down to at the end of the day. If you want representation, you want to protect your interests, you need to find out who out there is properly representing your interests right now. If the organizations that are out there that claim to be into doing your interest, I would, to protecting you, I would say ask them some questions, ask them the hard questions as to what are they currently doing right now? What have they not been doing in the past? What are they doing? What have they done in the past? What are they going to be doing in the future or not doing in the future? Start asking them questions like, what about the Taylor case? What do you feel about that? What about the Singer case? What's going on there? What about the FAA reauthorization coming up in here in September 2017? What about all of those? What do you think about Section 336? How do you plan on dealing with the FAA? Are you opposed to going head to head with the FAA in a lawsuit if they don't properly respect the boundaries that have been set by law? I mean, those are all good questions that need to be asked, because there are a lot of people that are all claiming to represent the interests of their constituents. But I think upon digging a little bit deeper, people will realize that people are far more interested in the bottom line and getting membership and saying whatever they need to do, to get people in the door, than they are in actually going toe to toe and constituents, if worst case, me be going to a court. So
I did not hear that.
Jonathan's dead right. It has to be an organized thing. There has to be some money behind it. And I tend to think the best structure is going to be regional groups with an overall global body to which those groups belong. So because Jonathan's talking about FAA, but you've got Transport Canada, you've got CASI, you've got CAA in the UK and New Zealand. It's more than just America. And I think maybe we need to have something that's sort of structured with regional centers in different countries, and then they have a central overall umbrella organization. And it's going to cost. It's going to cost. People are spending thousands of dollars on drones. The price of a cup of coffee every month is probably not a lot of money to us, but then it gives the people who are doing the lobbying and the lawyers, it gives them the money they need to do an effective job. So yeah, I think it's time for us to actually start making moves in this area.
Well, I think we're holding back again. We've got the futures sat patiently listening to the old duffers talking, but the regulations are holding back their futures. Did I hear, Jonathan, that some people have been quizzing the makeup of a recent committee over there and how the faces managed to get onto it?
Oh, well, yeah, there's people kind of wondering how certain parts of these drone advisory committees, the safety committee, all these different committees that are popping up, even the remote ID, how are these people being selected? And what's the criteria? And also additionally, what is the makeup currently, who's gotten on it? And so there's a lot of discussion there as to how that is all going down. Even looking at the drone advisory committee that's going on. Just kind of an interesting cross section. I mean, if you kind of boil that all down, how many of those people are actually like small businesses? Large majority of those companies are all large companies that have been in some other sector and have moved in, like Intel, where they're smaller, or they're smaller drone companies that have venture capital backing as well. But you don't see anybody that's like a small guy there. And even with the service providers, I mean, you have like Measure and stuff, but I don't think that's a proper representation of the overall market out there, if you will, of the makeup of the industry. So there's kind of are we having proper representation that the FAA is actually, picking enough people on there to, give something close to a proportion of what's currently the industry makeup. So that's one big discussion right there. And then, what was the criteria for choosing all these companies? What was that criteria?
Yeah, I wanted to ask, we've got three, I think, newly minted Part 107 pilots with us here. Guys, chaps, do you feel represented? You've got your Part 107. Who are you going to turn to if there's any troubles or woes in your piloting life now? Do you feel represented? No.
Yeah. Yeah, we feel really good about ourselves passing this test, and we feel like we can make a future out of this if we choose to.
But do you think if you got into, do you think then regulations, you've just had to study the regulations and you've had to pass a testing and all, do you think they are reasonable? And do you think that your interests moving forward are being looked after?
I mean, I would say some of them are unreasonable, but a lot of them are. And I feel like it's a fair thing and something that we can move far into.
Fair enough. Okay, similar sort of questions over to Jake and the students there. How do you see the regulatory environment, and how does it affect your global mega corporation that you're building?
I think the regulations kind of came down on us. I would say, and was it a year or 2 years ago? The FAA and the government was actually sending these type of emails of these restrictions, like the 400 feet and all that, to our district personnel, our insurance team. And when they see that, they immediately just freak out. So someone who knows what they're talking about to talk to them and to reinforce to them, what it is that we're doing, explain these type of rules, before they start getting all freaked out. Because I immediately got emails, no explanations or anything, saying that we're done. We have to end it. But before they even opened up the email to even look at it and to read what the regulations were, even was. So for me, it was, I had to then go to the district and pretty much say, hey, did you look at the rules? We don't go past 400 feet. We never go line out of sight. We never travel over houses. We never go over people. We don't operate any type of crazy ham type licensing. We don't do. And so when these ladies hear that, they go, oh, that's not that bad. And then they start, okay, so now they cover us. It was straight, you're done, until someone had to fight for it. And for these kids, a small percentage of them are going to get into the aeronautical field. That's the point of the class, and the point of FT STEM is just to get these guys into a situation where they have to critically think and to engineer and solve a problem. And our lens just happens to be aviation. So, it's more just bringing the school board and bringing the superintendent and bringing the insurance group over to our school and saying, look at what the kids are doing. Does this look like it's going to harm anybody in the area? And the answer, they go, this is crazy. I can't believe that they're regulating this. These guys are harmless, and this is so good for them, and blah, blah, blah. You know how it goes. To the point where it's, let's cover you. Let's do what we need to do to cover myself. Let's do what we need to do to cover the students just in case there was an accident. And let's keep moving forward and just pay close attention to what the FAA is doing. But in terms of, a senator coming into Colorado, and because he had a drone hit his car or something like that and says, we're done, that's gonna be tough. But that fear is definitely out there. but I'm not going to stop until I get some FAA official that walks right into these doors and has to tell these kids that they're not allowed to do what they do anymore. No email is going to stop me from doing that, which might get me in trouble, but this is for them. It's what I believe is what's best for the students. And if you want to shut it down, then you're going to have to come and tell them that they can't do that anymore. Political or not.
I think for it is very cool, and you can see that again. I'm going to gush, but there are so many areas: the video production, the CAD CAM, and just working as a team, whatever the project is. That's also very important moving forward. But it's Bruce. Really, this would be another unintended consequence of poor or ill-judged regulation, would be to shut this sort of thing down, I think. And perhaps that's where you're probably Bob on right, that there needs to be a sort of a more encompassing, less commercial organization for overseeing things or representing people.
Yeah, it's kind of like there's too many desk pilots, and we just need to educate as much as anything the people who are making these regulations, because they are shortchanging the young people of today. When I was a kid, flying models and that sort of thing, it was a footstep on the, a first rung on the ladder to aviation. And these days, if kids are sort of put off by the inordinate amount of regulation and red tape, they're just not going to take that first step. And we're going to find ourselves a little bit further down the track with a lack of engineers, a lack of people who have the skills and knowledge to properly make this industry grow.
Yeah, absolutely. No, we've gone over time again, so I better put the ban hammer down on the tonight's less pictured episode. Thank you very, very much for taking time out to join us, guys. I'm very impressed, and good luck in your futures, all you youngsters. I'm sure they'll be great. You're already doing the right things. Very, very impressed. Well done. Bruce, hopefully you're going to manage to repair yet more things. Oh, what about getting that Talon going? Where are we at with the Talon?
Well, I've decided to wait for a windy day because it'll be easier in the wind. But yeah, it's an interesting little exercise. I will not be beaten.
No, I'm sure you'll get there in the end. And I'm amazed how well it survived the arrivals it's had so far.
Yeah, it's a pretty tough airframe. Nearly as tough as my little DJI Spark. Oh, can't say anything about that.
Oh, we can't say anything about the Spark. Don't say anything about the Spark. We don't know anything about the Spark, Bruce. Moving on very swiftly. And Jonathan, I know where life's taking you at the minute, but hopefully you have a good rest of the week. And dear viewer, thank you very much for not watching myself, Jonathan, and Bruce, because we weren't allowed to be on the screen today. Please subscribe if you haven't already, and we'll see you again 2100 next Tuesday, same time, same back channel. Cheerio. Thanks very much for coming, everyone. Bye-bye.
Thank you.
Bye.